Aloha, welcome to AP Biology with Mr. Hardy. So today we're going to look just at some basic ecology vocabulary. So there's some language we want to make sure to get under your belt so you feel confident in some of the deeper, more complex details we're going to talk about. So first of all, ecology literally means study of houses in Latin. So eco, house, logy or ology, study of. So, but obviously we're not talking about houses so much as habitats and environments and where organisms live and feed and so forth. So we talk a little bit about ecosystems. An ecosystem is comprised of a level of organization that's comprised of all of the organisms living in a particular area, but also the abiotic factors or the non-living factors that influence those organisms. And so let's talk a little bit about the difference between biotic and abiotic. And so a biotic factor means a living factor, bio meaning life in Latin. So biotic factor is a living organism, and what makes it a factor is the fact that that organism is going to have an influence or an effect on other organisms. Populations include the organisms at the base of the food chain, what we call the producers. And producers have a big influence on everything that eats those producers. A carnivore is going to have a big influence because it's a predator on its prey and so forth. And so living organisms can be biotic factors, and abiotic factors represent those factors that are non-living. Abio means without life. And so an abiotic factor would be a non-living factor, but it will influence the living things in the environment. Many examples of non-living factors would include the water cycle, rainfall amounts, and so forth, if there's fresh water or salt water in an area. Another non-living factor would be the carbon cycle, the amount of photosynthesis happening. So the stored carbon within a forest and so forth, or the dissolved CO2 in the ocean. Another non-living factor would be sunlight, the amount of it. If it's getting a lot of sunlight near the equator, 12 months of the year, or limited sunlight during the winter, quite a bit more in the summer if you're in the northern or southern hemispheres. So non-living factors could also include natural disasters, floods, volcanic eruptions, fires, and so forth. So those are the abiotic factors, and ecosystems represent both non-living and living factors and how they all influence a particular area. So next step would be, how do we measure energy? And so there we're looking at food chains and food webs. So a food chain just shows energy flow from the producer all the way to the top level consumer. So your producer to your top level consumer. So once again, we have vocabulary here. What is a producer? What is a consumer? So a producer, also known as an autotroph, represents an organism that's capable of making its own energy source, food source. So autotrophs represent those that can do, these are your plants, your algae, sometimes what we call our cyanobacteria. These are all examples of autotrophs because they're able to do some sort of photosynthesis. And they can generate a food source from carbon dioxide and water using the sun's energy to drive the process. So autotrophs become the photosynthesizers, those that make food out of raw chemicals and so forth. They're producers. Consumers, on the other hand, the other name for that would be heterotrophs. Again, these are Latin Greek terminology. Hetero means other, troph means to devour. And so a heterotroph literally means other feeding or other eating. And so heterotrophs eat other organisms for energy. And so they get their energy by eating the stored molecules within the body of an autotroph or another heterotroph. Okay, and then finally we have an odd group called the chemotrophs, sometimes called the chemoautotrophs. Same basic idea, but a chemotroph, they're able to eat a non-organic molecule as kind of an energy source. Chemotrophs often are in the form of archaebacteria. Archaebacteria are those organisms we think were probably most similar to the types of organisms that are on Earth at the beginning of life on Earth. So when Earth was a much less hospitable environment and where they didn't have other organisms to feed off of, these were the organisms that evolved to eat things like methane gases or live in sulfur hot springs and eat some of those basic chemicals, phosphorus, phosphates, sulfates, so forth. Chemicals that are non-organic. They're not connected, not carbon connected to oxygen like a carbohydrate or a protein or a lipid, but instead are able to generate energy off of less organic molecules. Those are the chemotrophs. They also happen to be the producers at the bottom of the ocean. So you'll have those like sulfur hot springs at the base of the ocean, and down there's no sunlight, and so there's not the ability for a true autotroph to be the base of the food chain. And so instead, those chemotrophs often become the base of those food chains because they're the producers of, they can turn inorganic to organic molecules, and then other organisms can feed on them, and so they become the base of the food chain. All right? And so here's some real basic vocabulary. In addition to food chain, or the ability for energy to flow from a producer to a consumer, what if we connect a whole bunch of overlapping food chains and combine them all to get a bigger picture of a whole community and how the energy flows in that community? And that's what we call a food web. So a food web would represent overlapping food chains, all the basic energy flow organization in a community. So food webs are important because they help biologists understand the interactions among many of the organisms, where organisms might be competing for a food source, where organisms might be affected by the loss of another organism, and so forth. And so these just look at a more complex picture of energy flow within ecosystems. And two vocabulary words that go along with this are direct relationships and indirect relationships. So when organisms are in a community and they're interacting together, a direct relationship, this would be your predator-prey type relationship, or even a parasite eating a host, but this just shows energy flow. This shows your energy transfer. And so if I've got some grass in an ecosystem and I have an organism that might be eating off of that grass, for instance, I might have a grasshopper, and that grasshopper is eating the grass. Well, this arrow right here, this arrow shows a direct relationship because it's showing the energy flow from the grass to the grasshopper. Okay? There might be another organism that's eating off of that grass. Let's bring over an ant. All right, another little guy. Okay? That is a beautiful ant right there. Okay, so here's my ant. And then we'll have a direct relationship there as well. So the ant is also eating off of the grass. So these two organisms then are competing for the grass as a resource. And so what we do is we create a dotted line with arrows pointing both directions, and that dotted line represents an indirect relationship. Okay? Because both organisms are competing for grass as a resource, that creates that indirect relationship. So this is competition between two organisms for a resource. All right. One of the common misconceptions about indirect relationships might be you have the grass and you have the grasshopper, and then you have a bird eating the grasshopper. And the bird and the grass are indirectly related because, well, if there's not enough grass, then the grasshoppers die off and then the birds die off. So the grass and the bird are indirect related. Well, while that's true from just an English standpoint, that they are indirectly related, the definition of an indirect relationship from an ecologist standpoint is where there's competition. So careful there, don't misconstrue multiple levels of a food chain as indirect relationships. It's much more specific to competition between two species. And that competition could be for a food source, but it could also be for another habitat component. So it could be competition for water, or it could be competition for shelter, things like that. So a bear and a mountain lion might have an indirect relationship because they're both fighting for the same tunnel or cave to live in and so forth. And so there's a bunch of your basic vocabulary. We'll do vocabulary part 2 next.